Hi, welcome back to this video. We still in chapter alkene. So this is the second last video about the alkenes. If we look at the learning objective K and L, basically they are quite similar, where we can simplify that these two learning objectives, actually we want to discuss about the oxidation of alkenes. Okay, so basically we already learned how to prepare alkene. Okay, we have a tool. We can use alcohol, and we also can use haloalkane to prepare alkene. So then in alkene, we already learned about the electrophilic addition, where involve 5 reagents: hydrogen with the catalyst, and then halogen with the halogen in the solvent, and then we have the halogen in water, and then we also have acidified water and acidified water and also hydrogen halides. Okay, so in this video we will more focus on oxidation of alkene. Okay, with basically we react with ozone, hot acidified KMNO4. Okay, so these two conditions. Oh yeah, before we continue with the oxidation of alkenes and also the chemical test, maybe we can look at tutorial question 6b, which last few video we only discussed question 6a. Okay, so synthetic pathway is how the pathway that you're going to produce one bromo from 1,2 dichloropropane. Okay, so from here we know that try to draw the 1,2 dichloropropane, from 1 propanol. Okay, so means that the propanol is the reactant and the 1,2 dichloropropane is the product. Okay, 1 bromo, 1 propanol, so will be CH2, CH2, CH3. Okay, and then our purpose is to produce 1,2 dichloropropane, CH2, CH3. Okay, so when we in this chapter, when we look at the alcohol, we know that alcohol can produce alkene. Okay, so maybe it's from here. Means that we have no one step can from alcohol to 1,2 dichloropropane. So maybe we'll go through few steps. So from alcohol, we know that if react with concentrated H2SO4 with the heat condition, it will become alkene. So by remove the water, so the product will become CH2 double bond CH and CH3, which this is the alkene. And then alkene undergo electrophilic addition by react with the chlorine with the presence of C2Cl2 will undergo electrophilic addition. Okay, so recall back. This one, the type of reaction is elimination. Alcohol eliminate water to form alkene. So alkene undergo electrophilic addition by react with Cl2 with the presence of CH2Cl2 will gain the 1,2 dichloropropane. So this is why in this organic chapter you have to do some memorization and then relate to each other. So it is very challenging and very fun. So continue, remember the formula and then try out with more questions. Then you will find that it is very fun. Okay, after finish the tutorial question 6b, now we enter to the main point in this video, oxidation of alkenes. Okay, so basically it means that the alkene will going to react with oxidizing agent. For example, in this case is potassium permanganate and and also the ozone. Okay, besides undergo the oxidation, actually this process, the main purpose is to determine the position of the carbon-carbon double bond. Okay, so here generally we have three conditions, okay, three types of oxidation. One is with KMnO4, and then is basic condition and cold temperature, okay, cold condition. So another case you can see here, we also use KMnO4, but this time the medium is acidic medium, and then the condition is hot. So means that no matter with which condition, cold or hot, okay, with acidic or basic medium, there is the reaction, but for sure the product will be different. So that's why we study, make it to two different parts. Okay, another one is ozonolysis. So I think we will start with the ozonolysis in next slide. Okay, let's look at ozonolysis, which means the alkene will react with the ozone, O3. Okay, so from the words lysis, here we basically we know that's one they are going to break down. Okay, so what actually is breakdown? Try to break, in this case, because this is alkene, so we're going to break down the carbon-carbon double bond. Okay, so break down the carbon-carbon double bond. So again, ozonolysis means step number one, we will pass through the ozone first, followed by zinc with the presence of water or acidic medium. Okay, then next, like just now we say, it will break down the double bond. So like will look like this. And then at the double bond here is very simple. You just add on the oxygen like this. Okay, now maybe we can look at the example. Okay, question number one. Let's say we have this 2,3 butene. So once we go through the ozone with the presence of ozone followed by the zinc in acidic medium. Okay, so we'll break down the double bond. Okay, so when you consider break down the double bond, we will get like this and then add on the oxygen. So basically ozonolysis is very simple. You just break the double bond and then add oxygen at the double bond. Okay, now second example over here. Okay, so if again we break down the double bond, so over here we add on the oxygen, and then at the double bond here we also add on the oxygen. Okay, nothing else, very simple, right? Okay, then now we look at one tutorial question, objective question. The structure of alkene can be analyzed by using ozonolysis as shown below. Like step number one, alkene react with ozone will produce ozonide. Okay, which this one actually we don't need to write it down when we are doing the equation. Okay, we can directly give the final product. And then step two, that's why we say followed by hydrolysis. This one, the step two is the zinc H2O. Okay, it will produce propanol. So as we know, propanol have 3 carbon. And then when the name is end with O and E, so we know this is the carbonyl. The functional group is carbonyl and then is ketone. So C double bond O will be at the middle here. And then methana means that we have 1 carbon. And then double bond O, methana A and with Al. So means that this is aldehyde. So if aldehyde, we have C double bond O, H. Okay, this one is ketone. So and then one more thing, carbon always have 4 bonds. So now here already have 3 bonds. So means that we still need another 1 more bond. So for propanol, we complete the hydrogen CH3. Here second carbon already have 4 bonds, and then the third carbon we need another 3 bonds. So now they want us to predict what is the alkene. So before this, we say that if there is alkene, we will break down the double bond and then add the oxygen. So now we're doing the reverse process. So what you are going to do is you try to change the position like this. Okay, CH3, C double bond O, you try to move to the right hand side over here. And then this CH3 means that these two, they are going to change the position, yeah? Okay, the O and CH3 change the, actually it's not change the, only change the angle. Okay, so now here will be CH3. And we know that this is oxygen. Okay, so oxygen over here. And then for this one, we make it like here, CH, and then this one also H, and then double bond O. Okay, so same case as well, the double bond O and the hydrogen change the angle, top and the left hand side we change. And then now, because we want to get the alkene, so we imagine these are the products. So if we want to know the alkene, that means we have to imagine before the ozonolysis happen, there is no oxygen. So you erase the oxygen. So this is the double bond that you can consider like connect back this double bond. Okay, so when you look at here, so 1, 2, 3 carbon. So and then here is the methyl. So will be 2 methyl propene. The answer is A. It's that simple, just like mix and match only, right? Okay, now let's continue with the reaction of alkene with hot KMnO4. So this is the second one, where with hot KMnO4, the condition is acidic condition. So basically, the idea is still similar with the ozonolysis. You will break down the double bond and then add the oxygen. But this one, when react with KMnO4, for sure it is a bit different when with the ozonolysis. Okay, so like this case, the first case, as usual, we'll break down the double bond and then add the oxygen. Okay, so this is similar. Okay, second condition, when we break down the double bond, so you will have two conditions like this. Okay, only you have to remember that if there is alkyl group like this, we have two alkyl group, so we just add oxygen. If for second example here we have an alkyl group and then we have a hydrogen, you have to add the oxygen over here as well. Okay, so that means we have two places we need to add the oxygen. One is next to the hydrogen and then one is at the double bond. Okay, then now the third example over here, we also break the double bond, but then you will notice here we have two hydrogen, and then for this one is alkyl group, definitely we just need to add oxygen at the double bond. So when we have two hydrogen, it will become carbon dioxide and water. Okay, means that the oxygen will add to here, oxygen O2 add to here, so to form carbon dioxide and water. So again, we do the summary. So for the hot acidified KMnO4, same case as the ozonolysis, break the double bond and then add the oxygen next to the double bond. Then you have to look at if the two groups are alkyl group, the two single bonds are attached to the alkyl group, then it is fine. You already finished done the job. But let's say among the two, between the two single bond, there is one hydrogen, so you have to add oxygen into next to the hydrogen. So to keep in mind that the way you write is the oxygen bonded to carbon. You cannot write the hydrogen bonded to carbon. Okay, this is wrong. Then if there is two hydrogen in this case, so this one totally will become, this part will totally become CO2 and also H2O. Okay, let's look at tutorial question 13. When we look at the question with paragraph like this, so it means that in this question, it will involve more than one reaction and maybe also will relate with other chapters. Okay, for example, as we know, alkene react with hydrogen will produce alkane. Okay, and if alkane undergo halogenation with the presence of UV, will produce haloalkane. And haloalkane undergo dehydration with the reagent KOH in ethanol, and then heat will produce alkene. Okay, so you can see that there is like a relationship relate to each other. So that's why in this organic, you will learn how to relate all these chapters together. Okay, so now let's look at this tutorial question, question 13. Dehydration of 2,3-dimethyl 2-butanol with the reagent X will produce 2 alkene. So basically from here we know alcohol produces alkene, so this X is concentrated H2SO4. Okay, and then the condition is heat lah, if they ask us about. Okay, so now we have to like roughly draw the structure first. 2,3-dimethyl 2-butanol, so 2-butanol, 2,3-dimethyl, CH3, CH, and CH3. So as we know, it will remove water because dehydration of alcohol. So maybe OH will be removed from here and then one is from here. So if this case happens, so the double bond will in between carbon 2 and carbon 3. So we will get this product. And then if the OH removed from here and then the hydrogen is removed from this carbon, so we will get the product CH2 double bond, CH3, C, CH3, H, and CH3. So which one is A, which one is B, we have no idea yet, okay, because there is no mention A is major or minor product, so we can just leave it like this first. Okay, then when A and B react with hydrogen in the presence of platinum, so same product C will be formed. So like just now we say when alkene react with water, with the hydrogen, so basically break the double bond, form 2 new single bond. Okay, so you try to imagine, break the double bond, form 2 new single bond, break the double bond, form 2 new single bond. So when we look at the structure now, CH3, CH3, CH, so CH3, C, CH3, H, so both these are the same. Okay, so here we know the structure C will look like this, CH3, C, CH3, H, hydrogen, CH3 and CH3. Okay, so now we get back the alkene first so that we can refer it easier later. So the double bond over here and then the double bond over here. Okay, but in between these two alkene, we still no idea yet which one is A and which one is B. Okay, but we confirm that this is the structure for C. Okay, then now here they say ozonolysis A will give D, only one product. Sorry, I think just now here the double bond is at here, sorry. Okay, ozonolysis of A give D. Okay, so when we look at here, we know if undergo ozonolysis means that we are going to break down double bond. Okay, break down carbon-carbon, double bond. So if you break down the double bond over here, you will look at here, left and right are the same. Okay, but if you break down here, left and right are different. So basically we know the green one is the A. Okay, because only will give one product. C3H6O, so when you check here, 1, 2, 3, 3 carbon, hydrogen, 6 hydrogen, and then after you break the double bond, get one add oxygen next to the double bond. So it's CH3, CH3, double bond O. So this is the structure for D. Okay, so next they say that if the B, however, when B react with hot solution of potassium permanganate 7 will give E, water, and carbon dioxide. So we know that in the previous slide we studied if water and carbon dioxide are produced, means that the carbon and the double bond have 2 hydrogen, which yes, here we have carbon and the double bond have 2 hydrogen. So means that after react with hot solution of potassium permanganate 7, hot acidified KMnO4, so this part CH2 will become CO2 plus water. Okay, and then this part double bond. So here we have the, okay, sorry, I think maybe I have to adjust a bit so that I can write the structure better. Okay, so here we go. Okay, so in this part CH2 break the double, add the oxygen at the double bond, undergo further oxidation will produce carbon dioxide and water. Okay. However, at here we will maintain the double bond and then carbon CH3, 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 H. So when we focus here, the double bond, okay, and sorry, the single bond, this single bond is bonded to alkyl group. This single bond also bonded to alkyl group, means that we only need to add the oxygen at the double bond. So this is the structure for the E. Okay, so if this is the structure for E, so the above alkene will be the B. Okay, so from here we already know the structure A, B, C, D, E. So here continue the question, state the reagent X. So I think just now we already discussed is concentrated sulfuric acid, and then draw the structure of all the product forms. So we already draw the structure A until E. Okay, so until here you will notice that actually when you're reading the question, at the same time you're also answering the question. Okay, you don't need to go through all the question and then do the question. Okay, while reading the question you have the idea, just like we discussed just now. You just slowly write down what is in your mind, and then you will know that the answer. Okay, and then when you look at structure D and E, you also you can double confirm if D and E correct, A and B also will be correct, and then structure C also will be correct. Okay, they are related to each other. Okay, so we already finished up to here. So the second part will be continued in next slide. Okay, let's continue with the second part of the question 30, which is here. Name the alkenes, form and identify the major product. Propose a chemical test to differentiate A and C. I think this one we will discuss in the next video because we haven't entered the chemical test yet. So we are not going to discuss the chemical test. Okay, so these are the structure that we draw. This is identified in the previous slide. This is A, and this is B, and then this is the C. Okay, so name the alkene form. So among A, B, C, we only need to name A and B because they want us to name the alkene. Okay, so not necessary you have to name all the products form. Okay, so here we have 1, 2, 3, and 4. So this alkene is 2,3 dimethyl 2-butene. While B also the same case, only the double bond is at the first carbon. So it's 2,3 dimethyl 1-butene. Okay, after that we need to identify the major product. So if we need to know the major product, we have to follow the St. Jeff rules. The one with more alkyl group will be the major product. Okay, will be the major product. So now let's identify the alkyl group. Okay, at the carbon-carbon double bond, 1, 2, 3, and 4. Okay, while for the structure or alkene B, we have 1 and 2. So that's why this is A is the major product and B is the minor product. Okay, so later we need, in next video, we are going to learn about the chemical test to differentiate A, which is the alkene with the carbon-carbon double bond, and C is the alkane without functional group. Okay, so when we look at the structure, C is carbon-carbon single bond is alkane. Okay, so I think we will stop here, and then in next video we will focus on the chemical test. Okay, and continue discuss the all the tutorial question, because some of the tutorial question is mix and match with others part which we haven't discussed yet. Okay, see you in next video. Bye bye.